Okay, we're going to be doing lead code 121, best time to buy and sell a stock. You're given an array called prices, where prices at I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So prices, they're here. So the prices are between 0, so they're all positive, right? So that means that's a nice thing. And the length is from 1 to 100,000, the length of the input array. But this is good because the way we're going to solve this is, because when you look here, the prices may be high today, low tomorrow. So you can't just do a linear scan, right? You can either use 2 for loops, like some sort of exhaustive quadratic solution where you have 2 for loops and you just calculate all the possible profits. Or what you can do is you can use some sort of dynamic programming, but basically the way we solve this is we maintain a minimum price so far, right? Starting from, say, this position, right? So when we start from here, we compare with our minimum price so far, and then we calculate the profit on this day, considering that we have the minimum price so far, right? And then we come to this date, we calculate the profit on this date, considering we have the minimum price so far. We come on this date, we calculate the profit, considering we have the minimum price so far, like that. And by the time we're done, we'll have a global variable that contains the maximum profit so far, right? So let's do this. So we'll create a variable to store the minimum price so far. We'll call it min so far, and we'll initialize it with, the good thing that they gave us is the prices here 0, so you can just initialize it with 0, or you could even initialize it with the first price, right, which is at this index, or you could initialize it with an infinite negative float at negative infinity. But for this, I think we're going to follow what the question gave us, because the lowest possible price is 0. So we'll assume that you haven't seen any price so far. And then our max profit. For the max profit, you can make it negative infinity, or you can make it 0, because on the first date, on the first date, you obviously haven't bought anything, so you have like 0 profit, right? But you can always initialize it to negative infinity, whatever. And the other thing is, they told us that if you cannot achieve any profit, return 0. So if we cannot achieve any profit, we'll simply return this, right? So now it comes to the iteration where we iterate through. We'll iterate from the first. For I in range, length of our input array is called prices. And then for each day, we will calculate. We first check. We check to see if we have found a smaller price, i.e. a new min so far. So we'll say if prices at I is less than min so far, then our min so far becomes prices, right? And then we calculate the profit on date I, considering we have the latest min so far. So this will be profit is equal to prices at index I minus min so far. Now remember that this will evaluate some value, but sometimes we may calculate prices at I minus min so far, yet we've just set min so far to prices at I. So this sometimes will evaluate to 0, right? So meaning the profit on that date is 0 for that date, because the min so far, the smallest possible price we've seen so far, is for that date, right? So then we compare to the max profit. So max profit is equal to, max profit is equal to the max of max profit and min so far. And then we return max profit. Okay, max profit. Oh, I said min so far, sorry. And profit. Okay, so we need to initialize this to to 0. Yeah, we shouldn't be using 0 at the start. We can either use negative infinity, or we use prices at index 0, because yeah, float, let's see, infinity. This should work, right? No, it doesn't work. So we're simply, so for this, I made a mistake in my earlier explanation. You're supposed to start with the initialized value at index 0. Yeah, sorry about that. But the rest of the code is correct, right? Yeah. And so let's do a trace so that we can see this. But yeah, don't make that mistake of using any other value here. You're supposed that we just consider the first one as the smallest value. And so let's do a trace of this, right? So I'm gonna pop it up. So this is our input. The input we're going to use is 715364. As you can see, it's not sorted or whatever, so there's the highs and lows, and that's why min so far, maintaining a min so far works. So I'm going to push this code back here so that we can have a look at our code. So we start at this point where we initialize the min so far. So our I, if you look at the diagram, our I is over here at index 0, 1, 2, 3, 4, 5. And we initialize our min so far to 0, to the value at index 0, so it becomes 7. And then our max profit, we initialize it to 0. And then now we start iterating. So for I in range, length of prices, so our I is over here. We check what is our price at I. Our price at I is 7. Is 7 less than min so far? No, they're actually equal, so we don't calculate that. We come here. Profit, what is a profit? It is prices at I, right? This does not evaluate. Prices at I minus min so far. So in the drawing we get 7 minus 7, which is equal to 0. Then we compare our max profit to the profit, right? Which one is larger? Whichever, you just pick, because they're both 0. So max profit remains 0. So we come back here, and if you look in the diagram, our I shifts to the next location. So we're now at index 1. We come back here. What's prices at I? Prices at I is now 1, as you can see in the diagram. Is 1 less than 7, which is our min so far? Yes, it is our min so far. If you look in the code, we're executing this now. Our min so far becomes 1, right? So this is the process through which we get the smaller value. So then we calculate the profit on date I. So the profit will be prices at I, which is 1, minus min so far, which is 1. So this will be 1 minus 1, which is equal to 0. We compare this with our max profit over here, and our max profit remains 0, right? So in the code, we come back to this location, right? So as you can see in the diagram, our I has now moved here. We're at index 2. So prices on date I is 5, right? So in the diagram, we update our prices. It's now 5. Is 5 less than our min so far? No, it's not. So our min so far remains 1, right? So min so far, prices minus min so far will be 5 minus 1, which gives us 4. So then we come to this here, max profit. Is max profit larger than profit? No, as you can see here. So our profit becomes 4. We come back here in the code. Then when we go back to the diagram, you can see that our I has moved to here, right? So we ask ourselves, so we update we come here, we update the prices at I. It's now 3. Is 3 less than our min so far? No, it's not. So we do not update our min so far. And then we come here, we calculate our profit, which will be, this evaluation false, which will be 3 minus 1, which gives us 2. Then we come down here, we compare our max profit to the current profit, and it remains 4. So we come back to this place in the code, right? And then as we can see, our I moves to the next position, which is at index 4. So we update our prices at I, which is now 6, right? And then is 6 less than min so far? No. So we do not execute this. Our min so far remains 1. So then we calculate our profit, which will be 6 minus 1, which will give us 5. Then we compare max profit, will become the larger of max profit and profit. So if you can see on the diagram, profit is larger than 4, which gives us 5. It's now 5. And then we come back here in the code. As you can see on the diagram, our I is now here. So we update our prices. Our prices becomes 4. Is 4 less than our min so far? No, so min so far remains as 1. This did not evaluate. We calculate our profit in the code, as you can see. In the diagram, it becomes 4 minus 1, which gives us 3. We compare with our max profit. This is less than, so our max profit remains 5. So then we come back here. Is I less than length of prices? No, it's not, because our I has now moved here. So then we simply return the max profit, right? So the max profit that we return is max profit is equal to 5. And this is a linear time algorithm, and it takes O1 space, right? And the reason is we didn't use like 2 nested for loops. We didn't use any other extra space. We simply used some form of dynamic programming. And yes, that's the solution for this problem. All right, thank you, bye. Oh, we need to check if it works, right? You can submit it here. And you can have a look. Yeah, it works. Voila. All right, bye.